Recording's rolling. It's Tuesday, October 21st. We're on lesson 4.2. Graphing polynomial functions. Okay, you guys have your laptops open because I'm going to take you guys through a couple examples. So to remind you guys what a polynomial is, it takes this form. For example, it'd be ax to the 7 plus bx to the 6 plus blah, 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 all the way down to some constant. So guys, quick review from yesterday. Can you have a negative exponent and still be a polynomial? No. For example, if you have x to the minus 1, it's that same thing as 1 divided by x. Right, which would create a vertical asymptote, which would not be a polynomial. Right? How about this? Can you have a fraction power like 1/2 or 3/2? Can you have that? Also, cannot have that either, because that's like 1/2 power would be a square root, wouldn't it? Which would not be a polynomial. So you have to have whole number powers on x, something like that. Okay, so what's okay, and then I'll walk you guys through a couple of demos on Desmos. You guys are getting Desmos up, and then you guys know Alex 4.1, 4.2, 4.3 is that's the next Alex's too. So the pre-recorded lesson has a bunch of examples of what you guys are about to see. So if you need to summarize those, of course you can on 4.2, or watch yesterday's, or read the book, or you can work on Alex, and I'll be walking around with you guys up. Okay, as usual. Right. So what's this about? Right. So we're looking at polynomials, and if you look through this lesson, there are a lot of tables. There's a lot of data given in tables. Look at this, like x, y values. Okay. I see table here, table here. And they bring a lot of realistic type examples. So the number of certified pilots by year starting from, I think, 1930. They go decade by decade. The number of backpacks sold. I'm just going to do an example with you guys that was, where is it? Number of car sales in millions starting in 2008. Right? So a lot of this is probably actual data. How can you take this real world data and turn it into a polynomial equation that you can map? So I'll show you guys how to do that. Now, another detail we're looking at is how can you find zeros or sort of find a window of zeros? Because zeros, those are x-intercepts, isn't that right? X-intercepts. Okay. Guys, look here. X is going from -2, -1, 0, 1, 2, 3, 4. Or so we're going left to right. Okay. Well, guys, look at the y value. Guys, here. Stop. Okay. Guys, look at the y values. It's positive, 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 negative. Guys, when you switch from positive to negative, is that the graph crossing the x-axis? Yeah. So that would be, so I could say there's a 0 between where x goes from 0 to 1. There's some place where the graph crosses the x-axis. Also, guys, look at this, -3 to +19 on the y-axis. So somewhere between x is 2 and x is 3, there's another x-intercept. Now, if you plot the data and put a regression curve through there and get an equation, you can find a more exact location that'll happen. Okay, so first one, let's map this onto Desmos. So I'm going to do two examples with you guys. We're going to do a basic polynomial, and then I'll show you guys how to create a regression curve. So everybody open up the graphing calculator. Oh, yeah. Guess where I am? Right here? Okay, so y equals, you can also do f of x. It'll also accept that notation. So I've got x to the power of 4. So x caret 4. And then, because if you have any question how I'm trying to do this, then let me know and I'll fill you guys in. X to the power of 4 minus 2 times x to the power of 3. And then minus x squared. And then plus 1.
Just give me a minute.
How do you do the power of?
Guys, if you hit shift 6.
Yeah.
Guys, shift 6. Right. Do you guys see? Here, look at your keyboard. Do you see the numbers on your keyboard? Does the number 6 have a little hat-looking symbol above it? Yeah, so hit shift 6. It'll give it a caret. Right? And then that'll make an exponent. Okay, so everybody knows how to make an exponent? So I wrote x, then shift 6, it created exponent. I can type that 4. Then hit the right arrow key, and I'm no longer the exponent. And I can type everything else. Okay? Right? Polynomial. Right? Oh, and here's the graph shape right here. Right? Oh, let's go to some properties of this graph, because you might get some questions like, what's the absolute minimum? And you guys could go here and say, oh, the x value of the minimum is 1.78, and the y value where it bottoms out is -3.4. You guys see that too? Right? Or how about there's actually another absolute, or I should say relative max and relative min. Right here at 0, 1 is a relative max, barely, because it just goes a little bit down to the left. You guys see that? Goes down. There's another relative min right there. So there's another relative min, right? Guess how many zeros are there? How many x-intercepts? 2. I see 2 right there, right? 1 here and 1 here. Right? In fact, you can pretty much pinpoint exactly where they are. You guys see that exact x value right there? Also right there? Well, down to many decimal places. Okay, you guys see that? Okay. If you have a polynomial with degree 4, oh, I should have asked you guys that. What degree is this? You guys would have said anyway. 4, degree 4, right? How many times could it possibly cross the x-axis? Up to how many times? 4. Yeah. Guys, the number of times. Here, guys. Focus here. Look here. Guys, stop. Look over here. Where's your laptop? Back on your laptop. Back over here. No, back on your laptop. I want you to do this with me. Come on. Okay. So, guys, whatever the greatest power is, that's the degree. That's how many times it can possibly cross the x-axis. I mean, I bet you can shift this down so that this little bit crosses, back and forth a little bit. Barely. Right? Okay, so let's clear that one out. And I'm going to do another example with you guys. So the one I got picked out ahead of time is on page 225. So this is one of the main puzzles. It's number 11. Now, I don't have this highlighted, so I don't think I even put this one in the main video, but all the highlighted ones I did. So I did a bunch of. But model of mathematics. So we're looking at car sales in millions of car sales by year, starting at the year 2008. So our x-axis is going to represent the time, like the year, and 2008 represents year 0. Okay. So I'll show you on Desmos how to make a table and then how to create a regression curve. Now, there's other ways you can do it too. Like if you flip back a page, it does tell you on page 223 how to do this on a regular graphing calculator. So if you have a TI-83 and you want to try it out, this will probably do it, this method. You can follow step by step. Or I Googled it. There's some websites that do this whole process. There might be different ways you do it. There's probably several ways. But I'll show you guys a Desmos way to do this. All right, all right, you guys ready? Make a table? So type the word table. T-A-B-L. You guys see it? And E?
Yeah.
No, as soon as I hit E, the word's going to disappear. Did that also work for you guys? Yeah. Did you write T-A-B-L-E? Bam! As soon as I type the full word, now it gives me a table. For your first x value, type 0. Everybody got 0 as their first x value? Then hit enter. So 0 represents year 2008. And then type 1. Okay? And then hit enter. Oh! It automatically gave me 2. Enter. Go all the way down to 8. Because once you have the first 2 x values, it picks up the pattern and it predicts. Now, of course, you can manually override this if you want to. I could change this to like 11 if I want to, but I don't. Right? I'm just going to go year by year. Okay, you guys get that? Now, the table in your book shows 9 different years. Guys, 0 through 8. Is that 9 different values? Yeah. Okay, so let's go to Y1. Notice it gives you subscripts X1, Y1. That'll be important later. All right, you guys ready for Y1? Notice I don't have anything on this table yet. So if I go back to the book, all I'm doing, is here. Camera reset. Okay. All I'm doing is I'm playing out this. Come on. Sorry, let's try it again. Come on. There you go. Okay. So this table right down here. So notice it says millions of cars, and conveniently this one decimal place says 7 point something, right? 6 point something, 5 point something. They said. Okay. Now some of these are scaled like 40 or 400 or something for different kinds of tables. So especially for Desmos, it might be convenient to slide the decimal over to get a place where it's easier to work with. Right. So I'm just gonna use those numbers. So that's where these numbers are coming from. I'm about to type. If you have your book, you can follow along with me. So year 0, 2008 is 7.659. 7.659. Right? That's to say there was more than 7 million car sales. The next year, 2009, 7.761. The next year, so that's 2008, 2009, 2010, it's 7.562. Okay, everybody's typing this with me? Guys, everybody's typing this with me?
Yeah.
Okay, you got your laptop?
Yeah, right here.
Okay, you typing this with me?
Yeah.
Okay, everybody's doing this?
Yeah.
Okay. 2011, 6.769.
Yeah.
2012, 5.400. And Desmos keeps the 0, so that's interesting.
That's 2 zeros?
Yeah.
All right.
But that doesn't matter because it doesn't change the number. 5.635. 6.089. 7. 243. and the last number, 7.780. Right? Again, those are millions of car sales by year. Oh, look, it's been plotting a bunch of points for me. So I see year by year how many car sales in millions. Right? It's about like that. Right, you guys see it? Right. Now, I need to come up with some kind of polynomial that could fit that set of points. Right? Now, here's where it takes a little imagination on your part. You say, well, what kind of curve do I think would fit? And you can actually come up with different curves and just play around with it a little bit. Do you guys think you could put a straight line? Like, how many of you guys think a straight line would represent that data pretty well? No, I don't think so, because it starts off a lot of sales, and then the car sales dip for a few years, and then the car market comes back, and a lot more sales. Okay, so you need something that dips down, comes back. I think a parabola would probably fit that better than a straight line, and maybe even something to the power of 3 or power to the 4. We're going to try all those. Okay, let's try one of each until we get something that matches pretty nicely. So go down to box 2. You guys see, click below the table to 2. Right, so you guys where I am? Right. Now type this with me. Type Y, and then you have to hit underscore. So I have to hit shift and underscore to get a subscript. See how the cursor is blinking like a subscript? Okay. Guys, who does not have the subscript going right now? You have to hit underscore. Okay? You know how to hit underscore? Yeah, go ahead. Okay. Let me get you. So it's you hit shift and this key. Okay, and it'll give you underscore. Okay, so everybody's got underscore right now? Okay. Then type 1. Type 1. Okay. And then hit the right key to get rid of the subscript. Okay. So Y sub 1. Okay. Now, if you notice back at your table, also Y sub 1. Ooh, look at that. See, there's also an X sub 1. So all the X's we do have to put also those subscripts on there. Okay. So everybody can do subscripts. Now I hit the tilde key. I have to hit shift and tilde to get the tilde. Okay. So everybody's got the tilde? Right, got the tilde? That's good? All right. All right. Now, if I do something like K, well, okay, actually, they didn't do a thing. I was see if it was giving me a flat line, but it doesn't. Right. Let's do A X subscript 1. Right. And actually, if you just stop there, it does give you the best direct relationship that it possibly could, although that red line doesn't model that data very well at all. Right? But I mean, if you force it to. Right? But guys, can I do this? What if I do plus B? Ooh, no, there's a linear relationship that has a y-intercept. Right? So yeah, overall the data is kind of trending down barely a little bit. Right? But again, I don't think that fits it very well. So let's try a parabola. So I'm gonna backspace out of here. Okay, so everybody's got what I've got. Okay. Now I'll do to the power of 2, because aren't parabolas to the power of 2, like the degree 2, right? All right, then get out of the superscript. Then plus, I'm gonna do B X subscript 1, and then out of the subscript, and then plus C, right? Okay, so there's some kind of statistical method where if I wanted to force a parabola to represent the data, that's the best parabola that could possibly fit. Oh, and I forgot to point this out earlier, but see, it tells you what A, B, and C are, like exactly down to the, is it 10, 100, 1,000, to that, down to the 100,000th place. Okay, it tells you exactly what A, B, and C would make. Okay. Yeah.
But it doesn't like fit all the numbers.
Oh, why does it go through all the dots?
Huh?
What you're saying? Why doesn't it go through the dots?
Well, like, why doesn't it cover all of them? Only some of them are inside. Some of them are outside, some of them are inside
Okay, because there's different kinds of parabolas you can make. You could draw all different parabolas and take your best guess, right? But this is there's no better parabola to fit sort of through the points than this. Yeah, some points are above, some points are below, some are to the right, some are to the left. There's no single parabola that could go through all the dots, right? So this is like the least bad parabola, right? But again, it doesn't really model the data very well. So let's get even more powers. So I'm going to go back to this 2. Guys, let's make this to the power of 3, right? And I'll make this x to the power of 2. And I'll do C x subscript 1 to the power of 1, or, well, okay. And then plus D. Okay, so that's a polynomial with the degree of 3. Okay, that looks a little better, doesn't it? A little better? Right. But I think we can even do better than that, maybe. So let's try it to the power of 4. Or I don't know, maybe that is the best curve if you thought, right? So let's try to the power of 4. So I'm going to make this a 4, make this a 3, make this a 2, and then I'll do D, x subscript 1, well, to the power of 1. So just leave it like that, right? And then plus Right. Now, guys, if I want some constant on the end, I've got a pattern here. I'm going A, B, C, D. Right. You guys, if I type E, there's a problem with that actually. Do you guys know what E is? E is a very special number in math. Guys, what does E represent in math? 2.718. Yeah, yeah. If you said natural log, this would be the base on the natural log too, right? So don't actually type E because it forces it to cross. Oh, there it is right there, 2.71828. That's not what I'm trying to say. So you have to skip over E and just go to F, right? And then it will naturally pick the best y-intercept, in which case 7.55 something. Okay, right. Do you guys see every time I add on a degree, it's creating curves that fit this data better and better and better, doesn't it? Right? Okay. I might stop there and say, okay, I think that models the data pretty well. And then one of the questions that goes along with this is, can you predict ahead into the future? So if you thought that this polynomial modeled this data, what would it be for the next year? Like year 9? See, my years only go to year 8, but what would it be for like year 9? So I could go to year 9 and then find the y value and probably right about there. And I would predict that many sales, like millions of car sales. You guys got that? Okay. Is there any question about these so far? All right, hold on. Okay, so yeah, so that's the main examples there. A lot of these in this lesson are just like that. So, like I say, if you want to watch the full video and see a bunch of those examples, or watch yesterday's video, or you want to read the book, or if you want to hop on Alex and solve these 4-1, 4-2, 4-3, those are all good options to do. Whatever you think that best use your time, and I will walk around and help you guys out.